Hello everyone, welcome back to our channel. This is series 19, Ecotech Fusion Intelligent Ideas Next Generation. Come, let's go into the video. The first topic for today is development of eco-friendly heterocyclic inhibitors derived from biomass for mild steel protection in acidic nature. Here the research focuses on synthesizing and evaluating heterocyclic corrosion inhibitors derived from renewable biomass resources such as starch, celluloid derivatives and agricultural waste for protecting the mild steel in HCl environments, which are commonly encountered in industries like acid cleaning, pickling and oil refining. By converting these biomass-based compounds into heterocyclic molecules, say for example triosols, the study aims to create sustainable, biodegradable and non-toxic inhibitors that adhere well to the metal surface, forming a protective film that prevents acid-induced corrosion. Moving on to the innovation highlight, the first one is green chemistry approach. It utilizes agro-waste or plant-based precursors to create inhibitors, replacing conventional toxic petroleum-derived chemicals. Next is heterocyclic functionalization. It leverages electron-rich nitrogen, sulfur, and oxygen atoms into heterocycles to form strong adsorption bonds with metal surface. Next is cost-effective and scalable synthesis. Simple and eco-friendly synthesis methods for low cost and industrial scalability. Next, electrochemical and surface analysis. It uses techniques such as electrochemical impedance spectroscopy, potentiodynamic polarization, and SEM or EDS to analyze corrosion behavior and inhibitor performance. Comparative performance with commercial inhibitors. So here benchmarks new bio-based inhibitors against commercial synthetic inhibitors to demonstrate superior performance or eco-friendliness. Sustainable waste valorization. So it adds value to biomass waste by converting it into a functional chemical compounds for industrial corrosion protection. Moving on to the future scope, industrial scale application. So the development of eco-friendly corrosion protection formulation for use in oil, pipelines, storage tanks and heat exchangers. Hybrid coating system. Integration of these inhibitors into epoxy or polymer coatings for enhanced long-term protection in aggressive environments. Computational modeling and QSAR. So it uses density functional theory, that is DFT, and molecular dynamic simulation to optimize molecular structure and predict inhibition efficiency. Multimodal capability. It extends application to other industrial metals such as copper, aluminum or alloys in acidic or saline media. Regulatory and environmental certification. So it aims to reach EPA or BIS approval for safe deployment in industry focused on green compliance. Next is nano formulations, means it explores nano encapsulation or slow release delivery of bioinhibitors for control and sustained corrosion protection. Moving on to the next topic, automated foldable pedestrian overpass with weather responsive safety shielding. So here the project proposes the design and development of an automated foldable pedestrian overpass system for railway stations or busy crossing. The structure is mechanically actuated via hydraulic, pneumatic or motorized system and can be folded or retracted when not in use to allow for efficient space utilization. So the weather responsive shielding system automatically activates protective covers or panels based on real-time weather conditions such as rain, strong winds or extreme sunset. Finally, the bridge aims to ensure pedestrian safety and comfort, especially during high football periods, while remaining compact and energy efficient during off-peak hours or maintenance. Moving on to the innovation highlight, the first one is foldable mechanism. The pedestrian bridge is designed using telescopic or hinged platforms that can fold and unfold based on user demand or train arrival schedules. Weather responsive shielding. It is integrated with IoT sensors like humidity, temperature, rain or wind so that it triggers automated covers offering protection from rain, heat or dust. Smart control system. It controls using microcontrollers or PLCs and can be manually overridden or operated via mobile app or central station system. Real-time safety monitoring. It is equipped with ultrasonic sensor, IR motion detectors and CCTV for obstacle detection, overload alerts and emergency response. Energy efficiency. So it uses solar panels with battery storage to power the movement system and shielding mechanism during power outages or grid unavailability. Compact and modular design. So it easily can be assembled, maintained or transported, making it suitable for temporary stations or events. Moving on to the future scope, the first one is smart city integration. So it can be integrated into smart city infrastructure for adaptive pedestrian control and real-time traffic management. AI-based crowd prediction. So it implements ML algorithm to predict pedestrian flow and automatically deploy or retract the bridge accordingly. Multi-language voice alerts. It can incorporate regional language voice commands and alerts to improve accessibility and guidance for the passengers. Emergency evacuation mode. So here in this case of train accidents or crowd panic, the bridge can instantly extend or retract based on AI triggered emergency mode. Sustainable construction materials. So future iterations may use biodegradable composites or recycled polymers to enhance environmental sustainability. Mobile application integration. So it allows user to track bridge status, schedule safe crossing or get alerts on closure and retractions via smartphone app. Next is railway-wide deployment. Here it expands across rural and urban stations where fixed infrastructure is difficult or costly to implement. Moving on to the third topic, mangrove loss detection post-cyclones using transfer learning on CNN models and PlanetScope data. So here the project aims to detect the quantity mangrove forest loss following cyclonic events by leveraging transfer learning with convolution neural networks on high-resolution PlanetScope satellite imagery. So by comparing the pre- and post-cyclone images, the model identifies damaged or cleared mangrove areas with high accuracy. The transfer learning uses pre-trained CNN adapted to remote sensing datasets, significantly reducing the need for large labels dataset and accelerating model development. And finally, this enables the rapid environmental assessment of cycloning affected coastal zones, aiding in disaster response, ecological conservation and policy planning. Moving on to the innovation highlights, the first one, use of PlanetScope data, means it utilizes 3 to 5 meter resolution daily imagery from PlanetScope for fine-grained mapping, surpassing traditional 10 to 30 meter resolution sources. Transfer learning approach. It adopts pre-trained CNN architecture on general image datasets and fine-tunes them for mangrove classification, saving time and computation. Change detection pipeline. So here it implements before and after cyclone image comparison using semantic segmentation or binary classification CNNs to highlight the loss region. Next is time efficient mapping. So it enables rapid post-disaster mangrove damage assessment, reducing the field survey dependency. Next, Geo AI integration. So it integrates GIS layer, cyclone paths, tidal maps and topography with CNN prediction to analyze the cyclone impact factor. Edge deployment possibility. It can be adapted for on-field mobile deployment using lightweight CNN variants, say for example mobilet, for faster insights. What would be the future scope? Yes, smart city integration, global cyclone impact monitoring. So it means it expands the system to monitor the global mangrove zones under threat for climate-induced cyclones. Next is multispectral and SAR fusion. So here it enhances the CNN training to identify species-specific loss for better biodiversity impact analysis. Species level damage estimation. So it can enhance, say already said, the CNN training can identify the species-specific monitoring. Real-time alert system. It develops an automated cyclone-triggered AI alert system for mangrove damage estimation and reporting. Ecological recovery mapping means it extends the CNN model to monitor mangrove regrowth and restoration progress over a particular period of time. Finally, the integration with drones and mobile apps. As I already discussed, it combines satellite analysis with drone mapping or citizen science apps for ground validation and crowdsource monitoring. Moving on to the next topic, fourth one, deep learning assisted orthodontic treatment planning based on 2D and 3D image analysis. So here the project focuses on leveraging deep learning algorithm to automate and enhance orthodontic treatment planning by analyzing both 2D dental radiographs and 3D scans. It is using advanced CNNs and 3D CNNs or volumetric models so that the system can detect malocclusion types, jaw disalignments, tooth crowding, and growth patterns so that it can offer orthodontists a data-driven and consistent treatment suggestion platform. Finally, this approach can minimize human error, speed up planning, and also improves accuracy in diagnosis. Moving on to the innovation highlight, 2D plus 3D image fusion for comprehensive analysis. It combines 2D and 3D volumetric data for multi-view and multi-depth understanding of dental structure. Automated landmark detection. So deep learning detects anatomical reference point on X-rays and scans for precise facial dental measurement. Classification of malocclusions, that a CNN model can classify common issues such as class 1, 2, 3, overbite and underbite, etc. AI-driven simulation of tooth movement. It predicts the optimal tooth movement paths and treatment duration using patient-specific data. Next is reduce clinical overload. So it automates time-consuming process like cephalometric tracing and diagnostic prediction. Interpretable AI output. So visual overlays helps the clinical people to understand the model's decision, boosting trust and adoption. Moving on to the future scope, full integration into orthodontic software suites. So it is embedding with AI system into tools like Dolphin imaging for streamlined clinical overflows. Augmented reality for patients consultation. Here it uses model output to visually simulate treatment outcomes in AR for enhanced patient engagement. Multimodal fusion with facial scans. So it combines dental data with facial scan to assist in aesthetics treatment planning and surgery forecasting. Teleorthodontics enablement. So it deploys model in remote diagnosis platform to serve rural or under-resourced people. Continuous learning with patients' feedback. It uses reinforcement learning to improve AI accuracy based on real treatment outcome over a particular period of time. Cross-age adaptability. It adapts the model for pediatric, adolescents, and adult orthodontic needs with customized protocols. Hope it is interesting to know about different project topics which will help you in different aspects. Please stay tuned for more information. Thank you.